Hi everyone, I'm Shubham. I'm a master teacher at Vedantu. We are discussing JEE Advanced 2020, Paper-1, Mathematics, and the question for this video is this. Suppose A, B denote the distinct real roots of the quadratic polynomial x square plus 20x minus 2020, and suppose C, D denote the distinct complex roots of the quadratic polynomial x square minus 20x plus 2020. Then the value of AC, A minus C, plus AD, A minus D, plus BC, B minus C, plus BD, B minus D is what? Now here clearly the first equation has two distinct real roots, the product of roots being negative. And the second equation clearly has two imaginary complex conjugate roots, given that all the coefficients are real and discriminant is less than 0. Now what has been asked can be found out in a poor way by finding the roots A and B and C and D and putting them here. But there are better ways of doing this. One way is to club these terms systematically and use the concept of relationship between roots and the coefficients of the equations. Sum of roots, product of roots formulae can be used to effectively evaluate these terms and hence the final sum. Now this can be done in multiple possible ways. We can club the first two terms and the next two terms, or we can club the first and third terms and the second and fourth terms. We'll be seeing one such method in detail and the other I'll just show you through the typed solution. This question has four options. It is a single correct type question. Let's solve it. So here let me club first two terms. So here as I take A common, I would get A times C plus D. Check it out. A common taken, I get A times C plus D minus C square plus D square. Now here C plus D is sum of roots of the second equation, which is 20. So basically it becomes A times 20. And what about C square plus D square? I can write this as C plus D whole square minus 2CD. C plus D whole square will be 20 square, which becomes 400, minus 2CD. CD is 20, 20. So it becomes 40, 40, 2CD. So we can take 20 common, and what we get is A square minus A times 20 minus 1, 202. Yeah. So basically it becomes 20 times A square plus you get 182A. Now this 20 times A square plus 182A, this A square we can write using this equation. Since this equation has one of the roots, or this polynomial has one of the zeros as A, so I can say A square plus 20A minus 2020 equal to 0. So I can say A square is essentially minus 20 plus 2020. So A square is essentially minus 20A plus 2020. So minus 20A plus 182A is 162A plus 2020. Now by symmetry of the expression, if these two terms upon clubbing gives me this, I can say these two terms upon clubbing would give me 20 times 162B plus 2020. Now adding these two, I essentially get, when I take 20 common, I get 162 times A plus B plus this is 40, 40, 2020 plus 2020. So essentially it becomes 20 times 162 times, what is A plus B? A plus B is sum of the roots of this first polynomial, you may say, which is minus 20. Now again I may take 20 common. So I may take 20 common from this inside expression, and 20 times 20 outside would become 400, and the thing that I get inside is minus 162 plus 202. So basically it becomes 400 times, you may say, 40. So basically it becomes 16,000. So my answer is 16,000. So D is the correct answer. So this is the method that we have just now seen, and this is an alternate method, which is very similar to what we have done in method 1. Thanks for listening. Stay tuned for the next question.